Hello, and welcome to Mr. Ambrose's video on inverse trig functions. In class today, we established the inverse trig functions for sine, cosine, and tangent, and we also worked on some basic problems involved in those inverse trig functions. In this video, we'll examine more complicated problems that you have to be able to handle that involve these inverse trig functions. So to begin, let's consider the following example. In this problem, we are asked to evaluate the sine of the arcsine of 1 over 9. Now, by order of operations and our understanding of composition of functions, in this problem we would start off with the value of 1 over 9. We would plug that into the arcsine function and get an answer. It would be some angle. And then we would take that answer, that angle answer, and plug that into the sine function to get the overall final result. Now, while we will be able to evaluate this a little bit later on, there's an easy way to come up with the answer here, because if you recall from our unit on functions and their inverses, the whole idea of the inverse function is that it undoes the work of the original function. So since in this problem we start off with 1 over 9, and we basically evaluate the arcsine function followed by the sine function, the final answer to this problem should just be 1 over 9. Now let's look at an example that's going to involve just a little bit more work than the prior one. Here we're asked to evaluate the tangent of the arcsine of the square root 2 over 2. Since we have the tangent function and the arcsine function, both of which are not directly inverses of each other, unfortunately the answer is just not going to be the square root 2 over 2. To evaluate this problem by order of operations, we should first consider to try to evaluate what is the arcsine of the square root 2 over 2. From class today, if you recall, when you're asked to evaluate the arcsine of any value, you kind of just want to work backwards and say to yourself, the sine of what angle gives me the square root 2 over 2. And recalling from our exact values, the angle that accomplishes this is 45 degrees, which is equivalent to pi over 4 radians. And this falls right into the domain of our arcsine function. So for this particular problem, we would be able to then plug in pi over 4 into the value for the arcsine of the square root 2 over 2. And now, all we need to evaluate is what is the tangent of pi over 4, or the tangent of 45 degrees. And we know that value is equal to 1, and so that would be our final answer. Okay, so let's look at another problem similar to the one we just did. Once again, we're evaluating, in this case, the sine of the arctan of negative square root 3 over 3. Since both sine and arctangent are not directly inverses of each other, we begin this process by evaluating the arctan of negative square root 3 over 3. As we did in class today, we would consider the tangent of what angle gives us positive square root 3 over 3. Now, I'm only interested in the positive square root 3 over 3 because I really just want to know what is the reference angle. Because if you recall from class today, the domain of arctangent runs from negative pi over 2 to pi over 2, which takes us into quadrants 1 and 4. Since in this problem, yes, we are dealing with the arctan of a negative number, we know our answer should be, our angle answer should be in fourth quadrant. And if we know what the reference angle is, we can rotate clockwise into the fourth quadrant using that reference angle just by assigning it a negative value. So, the solution to the tangent of x is equal to positive square root 3 over 3 would be pi over 6 radians, which is equal to 30 degrees. And in our problem, we can substitute in for the arctan of negative square root 3 over 3 an angle value of negative pi over 6. Because again, since we're evaluating the arctan of a negative number, we know we should be in quadrant 4, the reference angle of which should be pi over 6, and we can rotate into that fourth quadrant by just assigning that angle a negative value. Now the sine of negative pi over 6, we just have to evaluate that and we'll be done with this problem. As we've done all year, one of the things we should identify is what is our reference angle, and we already know what the reference angle is. Given the work we've done so far, our reference angle is pi over 6. Using that reference angle, we know that the sine of pi over 6 is equal to 1/2, and for our problem, since we are dealing with an angle of negative pi over 6, which takes us into quadrant 4, we know that the sine of negative pi over 6 should be negative 1/2, since in fourth quadrant sine is negative. Okay, so we made it this far, and I promise you that this will be our last problem that I'll go over with you. Once again, we're asked to evaluate here the sine of our cosine of negative 2 over 3. And as with the prior couple of problems, since both sine and arc cosine are not directly inverses of each other, we should begin by evaluating the arc cosine of negative 2 over 3. So we go off to the side and we try to think about the cosine of what angle gives us negative 2 over 3. Now, if you're sitting there and you can't recall exactly what this angle is, that's because, well, we don't really know what this angle is. It's not one of our exact values in our chart. So this will happen from time to time, and when this does happen, we go about answering this question just using a different method that we've seen before with trig functions, and that is to use right triangles. So over here to the side, I'll draw my coordinate plane, and next I'll have to determine exactly which quadrant I'll draw my right triangle in. To do that, I go back and I consider the fact that we are trying to find the cosine of what angle gives us a negative answer. Since the domain of arc cosine is from 0 to pi, we get negative answers for cosine by going into our second quadrant. So that's where I'll go and construct my right triangle. I'll put my question mark angle here at the origin, and we can label two sides of this right triangle by using SOHCAHTOA. The leg here, the adjacent side, I'll label it with the value of 2, and the hypotenuse I'll give a value of 3. And the missing leg of our right triangle we can solve for by performing our Pythagorean theorem. And when we set up our equation and solve for x, we find that x will equal the square root of 5. So our missing leg here will be square root of 5. Now, this right triangle, we can use that to really help us finish off answering this question. Because while we were trying to evaluate the arc cosine of negative 2 over 3, that will end up being an angle of which we'll never know the exact value for. But in the grand scheme of things here, ultimately what we want to try and do is we want to try and evaluate the sine of that angle, which is our question mark angle. And to evaluate the sine of Mr. question mark angle, we can do that by looking at the right triangle we just constructed. And so the sine of Mr. question mark angle would be equal to the square root of 5 over 3. And since our right triangle is located in the second quadrant, we know that sine is positive there, so our final answer would be positive square root 5 over 3. So this concludes this particular lesson on inverse trig functions. I thank you for tuning in to this wonderful lesson. At least I thought it was wonderful. But I hope this will definitely be helpful to you guys when you work on some of these problems tomorrow in class. Enjoy the rest of your day.